Let's now look at the sigmoid activation function. And as we have seen in past couple of videos, here we have the input values x that go from -10 to +10, and the input values are for the neuron A that we see here in the circle. And let's imagine that this time the activation function we are using is sigmoid activation function that does the calculations as shown in the green box on the top right. The calculated values are shown in the column A, which are right here. And the plot on the right hand side shows a blue curve. Those are the activation values calculated using a sigmoid function for the input values that go from -10 to +10. And the magenta dots are the values that are calculated on the that are shown on the left hand side. And we see that this is a completely different curve that we can see as compared to the previous plots that we have looked at, which is either the SELU, ELU, GELU functions. And if we want to take a look, these or mesh, the values for those tend to go past 1 on if the values are positive, and they tend to approach 0 if the values of x are negative. On the other hand, in case of sigmoid function, we see that if the values are less than 0, they do try to approach 0. However, if the values are greater than 0, if the values are positive, they tend to approach a maximum value of 1. Let's now look at the implementation, or at least how to use it using TensorFlow. Here we'll create a similar example as we have been doing in these couple of videos, is create a values for x. And for that we'll use tf.linspace -10 to +10, and we create 100 values of these. And then we use the activation function sigmoid, tf.keras.activations.sigmoid. We input the values of x to this, and then we can plot the values. So plt.plot x comma y, plt.grid, and then we have plt.show. So we should be able to see a nice plot, and here it is, a nice smooth S-shaped curve for the sigmoid. And as you can see, right at 0, we are at 0.5 on the y-axis. So in addition to this, we'll calculate the values using the relation that we also know, and we'll label those values as y2. And this is what we have. I'm just going to copy it right here, and then we can add the tf.math in front of it to do all the calculations, and again plot the y2 values, just overlay plot. And in the output we see that the orange plot is exact overlay on top of the blue line that we had earlier. So that's how the sigmoid function looks like. If we were to overlay the ELU function on top of this, it's going to be yeah, less visible, I would say. If we type tf.keras.activations.elu, you have the x values, and if we try to plot it, plt.plot, and have the x, y, elu there, the values for sigmoid are going to be much smaller, and so we see that the green line goes all the way up to 10, while the sigmoid stays down below with a maximum value of y is equal to 1. So that was how the sigmoid function looks like and how it compares with the other exponential linear unit function, ELU. We'll continue this discussion and look at yet another activation function in next video. Until then, please like, share, and subscribe. Thank you.